Hello. This is the first project video for Project 3. It's about the 8th time I've started taping it. What we're going to talk about in this project video is, what is Privet? What sorcery is Privet? So let's get to it. Alright. Boop. Here's your pq.h. I'm sure all of you have already pored over it and are familiar with it, and you've probably discovered Privet. Priority queue takes a Privet. What? What is a Privet? What is that? And here it is up here again. What on earth is this syntax? Why are there two parentheses right after each other? What is going on? This seems like madness. And it is. It's what's called a function pointer. And it is absolute madness, but it is useful madness, and we're going to talk about it. So, what I have here, I have my Julia's Child style, it's a binary search tree. So I pulled it out of the oven. It's already been prepared. Custom for this. Custom binary search tree. It's not balanced. Don't get excited. It's just the normal binary search tree. So we're going to run it. I have a breakpoint down here at this bottom line. So it's going to stop at that breakpoint. And we're going to go look at the tree real quick, just to make sure it works. So I put in 1, 2, 3, 4. 1 is the root, and then you just keep going right to get 1, 2, 3, 4. If we're not convinced that it works, we can do some fun stuff. Get a little shuffle-lead there, run it again, and boom. Now 4's the root, its left child is 1, and then 1's right child is 3, and 3's left child is 2. Sounds good to me. Looks pretty nice. Now, what we're going to do is we're going to make our BST tree reversible in a really weird way. And you're going to be like, why is this useful? It actually is kind of useful. It's sort of a toy example, because in a bigger example it'd be harder to show in the time that we have. So, let's tell the debugger to chill. Go away. Chill. Just go on. You can... Bye-bye. Alright. So, we'll leave that breakpoint in there. So what we want to do is we actually want to be able to control the behavior of the binary search tree from the main. And so what we want to be able to do is be able to give it a method that actually compares stuff. So, in your insert, you usually do one of these things. So what we want, actually, is rather than having the BST do this, we as the clients of the BST want to actually have our fingers in here and determine what's going on. So what I would want is... Oh, that's cute. I don't even know how I did that. Anyway, what we would want is this to actually be a call to a function, that then we can supply that function to the class. What? Bear with me if you're confused. We're working on it, alright? Confusion is a sign that you're about to learn. Alright, so here we go. What I want is some kind of compare function. And I want it to take D1 and D2 and return a Boolean. Okay? That's what I want to do. And so here I'm just going to return, is D1 greater than D2? Okay? So now this is totally visible to the main. It can be called by the main. Cool. But what's also interesting here is I want to actually give this function, I want to give it to the binary search tree and have the binary search tree use my function for comparison. So what I need to do is I need to have the binary search tree be able to hold what's called a function pointer, which is allow me to actually give it a function. So we're gonna have a variable today here that represents a function, and they're called function pointers. They're kind of scary at first, but once you get the hang of them, they're like some crazy magic. You want to talk something we're not going to ever give 201 students. Function pointer is one of them. All right, because you can do some dirt with it. All right, so here we go. Let's put into our BST, let's have it take a function pointer. So what does a function pointer look like? Function pointer? Like, what is the type of a function pointer? Well, the type of a function pointer is determined by what it takes as arguments and what it returns. So, essentially its signature. So let's just copy this signature. Let's rename it to just, let's make it underscore compare. And then we're done? But wait a minute. This just looks like I'm giving a prototype for a function, not having this be something like that is a function pointer. So we change that by adding this. So what this does is it says compare is not a function that this class is going to implement. Rather, it's a pointer to a function. So now I can do something ugly like this. BST will now take a bool comp int as an argument. Yeah. So that means I have one argument for this constructor, and it is a function pointer which takes two integers and returns a boolean. Is it gross yet? Oh, it'll get grosser. Don't you worry. All right. So now I'm saying this variable down here equals comp. So whatever function has been passed in is now, it's comp. Oh, so wait a minute. How do I send a function? How do I give it? How do I appease? Right, because your parameter list is this is the data for which I hunger. Right, so that's your parameter. So how do I give it one of those? Well, I've written a compare in here. So what I'm going to do is I'm going to send it the address. Come on, where's my ampersand? Of compare. What? Yeah, that works. Okay, but the compare is actually happening in insert, which means I want to give insert this as an argument. So I did. And there it is. And now I'm just going to do, now I'm going to use it by just calling it like it's a function, because it is just a pointer to a function. And it returns a boolean, so this will give me a boolean out of here. Nice. Right? Is that nice? Is that nice? I don't know. I don't know if it's nice. Alright, so let's run it, see if it works. Uh-oh, too few arguments to function call. Oh yeah. Oh yeah. Oops. Okay. So right now, we have like left, right, all this good stuff. Okay. Excellent. So our tree has this comparison function. And as you can see, a function pointer is pretty literally just a, hey, it's the function here on line 52. That's what this variable is. Cool. And so we make the tree like this. So let's go back to a tree with fairly straightforward stuff in it. Come on. Oh, I have to stop executing. Oh wait. Hoop. and hoop. Okay, so we know what this tree is going to look like. It's going to go shroomp. Now, you can see, oh, never mind. Larger numbers are going on the left. Okay, great. So if I wanted to change this behavior, I can change this function. And I can rerun. And now things should be going to the left. Excellent. So just do that again. Swap a roodle. So they're going to the left now. We're going to swap a roodle. And now they should be going to the right. And they're going to the left again. Why? Why are they? Why? Come on. Why are you going? Is it? Do I need to actually like rebuild this thing? They're going to the left. 2's in the left. Stop. Flip. Oh, do you know what I probably did? Because I'm dumb. I probably put the same sign back in. What do you bet that that's what I did? That I do that all the time. I'll be like, now let's flip this sign, and then I'll just delete it and put the same one back. Aha! Now it's on the right. Excellent. So what that means, and you're like, why? 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 Why are we doing this? What is going on here? Here's why this is cool. I can have, in my main, I can have a tree that puts the larger numbers on the right, and then I can have another tree that puts the larger numbers on the left while using the same tree class. Oh, what? Watch. Watch! Alright, so let's make this a for loop. Let's just put 4 things in here. I'm going to do tree.insert I. And then we're going to do tree2. And we're going to give it another compare function. Compare backward. Which we don't have defined yet, but that's okay. Compare backward. And this time I'll have something to compare with. Now we're going to run it. And we're going to see that tree 2 has a different insertion behavior than tree 1. Okay, so let's stop and then run it and look at our 2 trees. So here we have a root that has 0, and on its right is its 1 node. Here we have a tree that the root is 0 and the node is on the left. So what we've done here is we've made a class that we can just send the compare function in and change the way that the class builds itself. So one of these is building a tree where the normal in-order traversal will give you things in ascending order, and the other is giving them, it will give you things in descending order. A common use of function pointers is you give it to a sorting algorithm, and if you give that comparison function pointer, to a sorting algorithm, that will determine how the sorting algorithm compares to things. So let's go back to what prefint was. In the prefint thing was a type def originally. So what does that mean? Well, what we can do is we can clean up all this stuff, right? We could grab this and we could say, this is a comp function. So now we're defining this as a type, and I can just go around here and do comp function comp. And so now I don't have to put this big scary type thing in here. This now means that this is a function pointer to a comparison function. So this just lets me tighten up make my code a little less terrifying, right? Because when you look at this, it looks like there's a function signature inside a function signature. And we do enough turduckening of data structures in 341, we probably want to slow our roll a little and just do comp function comp here. That's easier to read. And down here, we would do comp function compare, or underscore compare. Now this looks more like a member field rather than a function declaration or prototype, right? Because when it was in here before, if someone's reading your code, they're gonna, if they don't spot this star, if they're just kind of glancing over it, they'll think that you're implementing the compare function in this class, but you're not. You're taking it as a pointer. Whereas, oh geez, no, redo. Whereas this, someone will look at this and be like, what the deuce is this? And they'll go up and they'll find the type def and go, oh, I should also have a semicolon here. Oh, it's one of these squirrely function pointer things. What's the problem? Why is it? Huh? Oh, I didn't make it an underscore. My nose is tickly. Okay. So that's a little tutorial on function pointers. So then let's go back to the project description and see what the heck prefint is. Prefint? Go back. Huh? Please? Pretty please? Oh, it won't while this is. So let's look at this now. Now that we know what function pointers are, we'll look at this and we'll say, we're defining a type here, prefint, and this is probably priority function type, is probably where this name comes from. And so this type is being defined as a function pointer for a function that takes a constant patient reference, or a constant patient by reference, and returns an integer. So when you see prefint here, this is a pointer to a function. And when you see priority down here, this is a pointer to a function. So you can call priority. You can do priority parentheses and then slap a patient in there. Don't slap any patients, but you can put a patient in there. Why is this useful? Well, we're going to have a priority queue for these patients. And so a nice way to be able to design this priority queue is we give it a function pointer, and that function pointer will take a patient and then compute that patient's priority. So what you can do then when you're making one of these PQ objects, sneeze. Oh my gosh, my mic is all the way over here. I probably sound like I've been in a hole this whole time. Oh, I'm going to keep it over here so I don't blast your eardrums out. Sorry about that. I don't have someone on the live stream being like, you sound like you're in a hole. Anyway, hopefully I didn't just blast your eardrums with that. Because the video is basically over. Yeah. So you can actually call priority in here, and you can make different queues of patients where their priority is determined by this one. One might determine it by the patient's heart rate, another one maybe by their blood pressure, or maybe it's a weighted average of different patient things. And so what this lets you do is you can create multiple priority queues that compute priority differently, but you don't have to rewrite the priority queue class each time. You just give it a different comparison function. All right, that's the first video. Sorry about the audio. I'm not going to record the whole thing again, because I've already recorded it like 5 times. All right, anyway, bye for now.